We have a lesson tomorrow?
Huh?
Do we have a lesson tomorrow?
Oh yeah, tomorrow I'm getting my maths test back.
Okay, so we can go through it. I think you did okay in this topic, actually.
No, but like it's like the test was like okay, it was easy until the loss section. And so that's bad because and I also made like three silly mistakes, which is bad because the test was only 28 marks. So if I lose like just like a little bit of marks, I'm like yeah, I won't do well. But let's pray that I only lost like 8 marks.
Why is my computer lagging? This is crazy. My computer should never lag. Hello, Ryan.
Hi, Michael.
没告诉我款筹咋样呢？
Oh my god, my computer is lagging. This computer should not lag. It's a really good computer. It should not lag like this. Oh my god, what is happening? Memory. Oh, what? This is very strange. This shouldn't happen. Can you guys hear me?
Mm-hmm.
Okay, my computer is kind of crashing. Huh. What? Alright, can you guys hear me?
Yeah.
My computer is lagging so much for the last like 2 minutes. I have no idea why. That was crazy. This shouldn't be happening. Alright, I think the lag spike is gone. That was very weird. Alright, so Hannah will be coming later and we'll get started early. Oh my god. Today I'm gonna do something different. I'm gonna do things differently. So I'm gonna try to keep, you know how normally for all of you I send screenshots of the notes, but this time we're gonna try to write everything in Word document, okay? We're gonna try to write everything like in here. I have a pen and this allows me to write in here. So let's try to write everything here and see if it's good, okay? All right. Before we what am I showing? Oh, I'm not showing the right screen. All right, so before we go into the new content, let's just quickly revise what we did last time, okay? So last time this was like 2 months ago. So can anyone tell me what is the function?
Is it like an input of something?
Wait, it's like an input, then it gives you an output.
Yeah.
Yeah, and then there's like the
Yeah,
domain, there's the range.
yeah, something like that. Adriana, I believe we didn't do domain range last time, did we?
No, I don't know.
No, okay. Yeah, I think we didn't do I'm pretty sure we didn't do domain range. I was just checking the notes. I think we didn't do it. We did it with I think I did it with Hannah's private lessons and maybe with you as well, Ryan. But I'm not sure in the public. I'm not sure if we did it in the group lesson.
Was I
So
here
yes.
for this? Like, I don't think I was here.
Oh, then no, then you can maybe catch up a little bit. So a
Okay.
function, yes, it's a thing that converts a input into an output. It could be very arbitrary. It could be defined like this. For example, here, this is a function. It takes 1 to 2, 2 to 4. So this is pretty much multiplied by, oh, not multiplied by 4. Whereas 4 is plus 2. It's plus 2. But in this case, the function is not just plus 2. It has a domain and range, and this is what we haven't covered, okay? Oh, this is not even plus 2. This is plus 1, plus 2, plus 2, plus 2, plus 6. So it's very weird, right? Yeah, so it's not a simple function. But it really is quite simple. If you just want to represent a function, just use this graph, right? One concept we're going to cover today is domain and range. So domain is the allowed input, okay? So pretty much the input, all the possible input is here, okay? So if you put something else outside that into a function, it will not work. It will simply be undefined. So that is what domain is for, okay? It restricts what you can put in. So let me quickly note down something. Well, I forgot the word. What is it called? Abstract. Oh, abstract. Yes, yes. So let's have a very abstract example. Okay. So let's say we have a function. Maybe I should share screen. All right, let's do a very abstract example. So if we have a function that takes a student name as the input, and it gives you the grade as the output, okay? So think about what would be our domain here. Okay, this is very abstract. It's not a mathematical concept. It's just some examples for you guys to understand what domain and range is. So the domain here could be maybe right now who do we have? We have Adriana. I'm just gonna use capital letters for you guys. Ryan and also Hannah. Okay. Yep. And that's our domain. So you guys are the students, right? If I pick a random person from the street in Sydney, I put it in the function would not work, okay? And then we also have the range. This is what we call, this is the possible output, okay? What are the range? In this case, the range is, okay, range really depends on what you get. For example, Adriana, you got let's say, what grade do we use? ATAR. Let's say you got like 95 ATAR. Ryan, let's say you got okay, I'm not gonna use this example. This is a bad example because it forces me to rank you guys, which is bad. I'm just gonna say, okay, I'm just gonna use randomly. Let's just say 3 students. We have 94, 97, and 98 for the ATARs, okay? So these are the possible ranges, okay? And then I maybe the function itself. Oh, yeah. The function is oh, okay. The function itself tells me which who ranks, or what am I saying? The function itself tells me who got which grade. Okay. For example, these arrows indicate like what the function will give us. Okay. Does that make sense?
Yeah.
Mhm.
Okay. Cool. So that's a very abstract example. We could also have a more specific example. For example, we have the function itself could be x squared plus 3. All right, can anyone tell me? Actually, not anyone. Adriana, please tell me if your x is 1, what is your fx? Actually, yeah, sure.
Is it f bracket 1? I don't know.
Okay. Yes, yes, it is. I'm asking what is f bracket 1. So,
Like-
okay, so if you don't know, this notation means you put 1 into the function. So you put 1 here and see what you get.
Oh. So it's 4.
So it's 4, yes. What about 2?
7,
Okay. What about 3?
12.
Sounds right. All right. Okay. So in this case, that's just some examples. Okay. The function itself is defined by this. And if nothing else is given, the reasonable domain and range, the reasonable domain would be, Ryan, what do you think the domain is going to be for this?
4 to 12.
No, this is just example. This is our function.
Oh, 94 to like. Oh, is that to the power of 7?
Oh, 2.
Squared. X1. Can't it be anything that is above 3? Or like
Why can't it be anything that's below 3?
and below? Oh, wait, are we doing the example one or the student grade one?
There are two different ones. Two different ones. Right now, I'm just resizing them.
Wait, which one are we doing?
This one.
X. It would have to be anything above 4 to infinity, wouldn't it?
Okay, what is your reasoning?
Well, if you put a negative number, won't it just become positive because it's squared and it's like algebra? So like it's
So
negative.
what are you
negative,
looking at? You're looking at
positive.
the output,
Yeah, I'm looking at the output.
but the output is range.
Oh my God.
Okay, good thinking. Good thinking. What is the input? What is the possible input here?
Can't the input be anything?
Yes, that's what we say. The input is, in fact, we say all real numbers. Okay,
Okay.
we just say all real numbers. So this is the notation for real number. It looks like this. It's an R with an extra line. Okay, I should write it out like this. But this
Okay.
means all real numbers. It's pretty much anything. Okay, don't have to stress too much about that right now. What about the range? Yes, you did mention something about the range, and I believe it's correct. So what did you get for the range?
Everything above 4 to infinity.
It should actually be everything above 3 because technically you could put negative number, or like technically you could put 0 in there, right?
Oh yeah, that's true. So okay. Yep.
Adriana, is there any question?
Wait, so is it like the domain is like the x values and like the range is like the y or the f?
Yes, yes.
Uh,
But you don't want to think about it that way because a lot of questions, they could be abstract. So you can have a very abstract definitions and then like the first one, okay?
okay.
But yes, if it's if you see an equation, then yes, you can think about it that way because oh, why is this not grouped? Oh, what? All right. All right, cool. Today we're gonna talk about domain range. I think this is actually pretty cool, like me writing stuff on the Word document, right?
Mm-hmm.
It's pretty easy to use as well. All right, so last time we didn't talk about it. What else did we talk about?
I don't remember.
Okay. Oh, we did talk about domain range. Okay, so we did talk about it. That's good. That's good. We had this very abstract notation, remember? Oh, wait, only Hannah was there? Okay, Ryan wasn't. Oh my God, Ryan wasn't there. Okay, and then Ryan joined minutes later. Okay. And then we talked about a very specific function example, and then we talked about a piecewise function and another piecewise function and some questions. Okay, so nothing too hard last time. So today we're gonna focus on some more advanced stuff. Begin with domain and range, okay? So I'm just gonna pull up some questions. Ryan, did we do this last time? 2D, I believe we didn't 2D. Oh, Hannah's here. Hello, Hannah.
Hi.
Hannah, did you do 2D in your own time? I remember I did leave you this exercise
Yeah,
like
but
a
I
while
haven't got
back.
to it yet.
Have you done it?
Not yet.
Okay, cool. So we can do it during this lesson. Because last time I leave this out because Hannah might have done that already. If we haven't, we can try to do this. So exercise 2D. All right. All right, so first question, state whether it's a function or not. So you don't have to write this down. You can just look at it. Hannah, first one, is it a function?
Wait, I can't remember if it was the input or the output that could be the same.
Think about, okay, I like to remember it as use the student example. So let's say if a student, you have students in the class, right?
Yeah.
And the output is the grade, input is student. The function tells us what grade a student get, okay? Maybe the function calculates the attendance and the test mark and everything all together, right? You can have two students with the same grade, but you cannot have one student with two grade. Okay. So you want your output to be deterministic. In other words, given the input, you must have one output only. Okay.
So is it is a function.
No. Anyone else?
Is it not a function?
So why is it not a function?
There's no output.
No. Ryan,
For which question?
question A.
Oh wait, I got X and Y mixed up.
Ah, okay.
So the X can't be the same, but the Y can be the same.
Yes.
Okay, yeah.
Yep. Yeah, and if I were you, I wouldn't do it that way. So don't think about what else if it's same. Think about input and output because whenever you don't have X and Y, how are you gonna do that? For example, this okay, this is technically you have X and Y. Yeah. Okay. Yeah, think about the input output. It's just that for each input you have to have a unique output, right? It's kind of intuitive, as I said, the student example. Okay?
Mm-hmm.
So this one's not a function. All right, anyone want to do B?
B is a function.
Why?
Because the x is different.
Okay, because we have 3 different axes. Okay, yeah, sure. And it's asking for, oh, why is this so thick? It's asking for if it is a function, what is the domain and range?
Domain is -5. Is wait. I get confused with the crocodile mouth. Smaller,
Oh, why do you need crocodile right now?
that stuff,
Hmm?
isn't it?
No, in this case, okay, why would you need crocodile here? The domain should just be these 3 numbers. Right?
Should you be the smallest and the biggest?
No, actually, no. In this case, we're not talking about a continuous line here. So we're only talking about, let's say, 3 random points, right? We're not linking them together. We're just talking about these points individually.
Oh, so just -5, -2, and 3.
Yeah, and you want to have this big bracket next to them, okay? Indicating it's a set. Okay.
Mhm.
This is just notation. It's not that important, okay? And the range is of course is the same 3 numbers, 4, 6, and 14, okay?
And do you write them in the order, like smallest to biggest?
Order actually doesn't matter. Set does not matter order. So let's say you have -1, 2, 3. This is the exact same set as this. -1, 3, 2. Maybe you can add a -1 as well. Set also ignores duplicated numbers.
Okay.
The definition of set is a collection of like not unique, collection of unique or whatever numbers. So yeah, it's not that strict. Just put a curly bracket around it. You should be fine. All right, C is exactly the same, except for you have this, but that's fine. It's 2 different input, same output is fine. Okay. All right, everybody, let's just do yes or no for everything, and then maybe we'll compare answers at the end. So I'll give you guys like 2 minutes. No, 2 to 5 minutes. Once you finish the yes or no, once you finish the yes or no, you can find the domain and range for the yes. Okay?
Do you want us to send the thing?
No, you don't have to. Hannah, why do you sound different today?
I'm a bit sick, sorry.
Okay. No, all good. It's just you sound, I can hear that you sound different. Oh, I actually just came back from New Zealand and I almost got sick as well. I was at Queenstown and I can feel the sore throat. Yeah, because I exercise regularly and then I didn't get sick, which is good. Like I only stopped at the sore throat and then I recovered, so it was pretty good. But yeah, if you're sick, drink water, eat vitamin C. Oh, I haven't had my vitamin C today. I should probably have it. All right, everybody, you can look into the camera. So drink water and then eat this kind of thing. This thing gives you a lot of vitamin C, which is supposed to hugely improve your immunity. And then yeah, sleep healthy. You never get sick in the rest of your life. I haven't got sick in ages.
Do we do all of them?
Yep. Just do one. of 1.
Michael, for K
Yeah.
and I, they've got like a pink and a green. Is that just saying there's like two?
Oh, this is piecewise function we did last time. It's the same function.
Okay, I get it.
Ignore the color. I don't know why they're doing different colors. It's
Wait,
kind of stupid.
I don't know.
Uh,
that. I haven't done it.
Okay, Adriana, look at K. I'll just tell you what it is. You
Is
put
it like
negative.
not a function? Oh, whatever. No, you can keep going.
If you put -1, you get 3. -2, you get 4. -3, you get 5, etc. Right? And then you put any value between -1 and 1 is undefined. You don't get an output. You put 1 in, you get 3. You put 2, you get 5. You put 3, you get 6. Does that make sense?
Kind of.
Yeah, so it's pretty intuitive. It's what the graph says. Let's say if I put 1.5 in, what do I get for K?
Like 1 point what?
If I put in 1.5, what do you get as the output?
What do you times it by? 3?
How did you get that?
Wait, I don't know what you're talking about.
Okay, I'm talking about question K. Okay, before we go to question K, do you understand question H?
Well, I just thought it was a function because it goes through the line, but I don't understand the
Nope.
concept.
Wait,
Ah,
H,
you missed too much.
Michael.
Yes. Okay,
It's
H is pretty much
H.
this. You both of you can listen up. So when we have a graph, a function is the same as y equal x, y equals something something x. It's just that it's generalized into a concept of function. And for example, H, we have a graph, right? The function, remember, is input to output. So H, what is the input here? Our x value is always the input, and the output is always y. And let's say we put in 1.5. Here we can see we get 3. So let's say here our function is f, so I can say f 1.5 is 3. So this is the input. This is the output. And let's try another example. If I put, let's say, -3 in, it doesn't have to be perfectly accurate. Roughly, what do I get, Adriana?
4.
Yeah, that's the concept function. You have an input, you have an output. This is pretty much the same as plotting a graph when you have y equals whatever x, right? Let's say y equal mx plus c. It's just that now instead of y, you have fx. Oh, I can't draw outside. Does that make sense?
Yeah, but like what about it makes it a function? Like I don't know how to like differentiate it.
Oh, yes, I forgot to tell you. It's not I forgot to tell you. Then come to the lesson. Yes, a function has one very important definition. You must have a unique output for an input.
So just like 1.
So you have, let's say we have, okay, let's draw a graph that's not a function. Let's do a counter example. So let's say we have a graph, right? This is your x, this is your y. If a graph looks like this is a circle, okay? Now, if you look at the input and output, let's say this is your input, right? It has 2 output. Does that make sense?
Yeah.
So in this case, it is not a function. So you can't even call it output because there's 2 different things. There's not a specific value, right?
Oh.
All right, Ryan, what was your question?
No, never mind.
You got it?
Yeah.
I think I'm covering some of the questions. I'll zoom out real quick. Yep, that's all the questions. When you finish the yes or no's, tell me.
I think I finished the yes or no's.
Okay, you can move
So
on
did
to
I.
the domain and range. If you finish the domain and range, tell me. We'll start explaining.
Oh.
In the meantime, Adriana, and Ryan, if you guys have any questions, feel free to ask me anytime, okay?
Wait, Michael, what does the two dots mean? Like F two dots X?
Where does it say that?
2C.
Oh, you're not supposed to do two, but
No? What?
did you finish one already?
Yeah.
And domain and range as well.
Oh!
Oh, okay. But for
Okay.
your reference, I'll tell you what that means. When you have F something and then something arrow, oh my god, the screen does not allow me right speak. Have F something, F and then two dots, right? This arrow, this is the input,
Mm-hmm.
this is the output. So it's pretty intuitive.
Okay.
So it's the same thing as F bracket X equals something. So that something is here, and that something is
Mhm.
here. That's the same. So it's take X to this thing. All right, anyone finish the domain and range?
I've got 3 of them. Oh, yeah, 3 of the graphs done, but I don't know how to.
Okay.
I've got, I think I've done them.
Okay, Adriana, which one you up to? Did you do domain and range, or is it just yes or no?
I'm doing the domain and range.
Okay, cool. All right, I think we can get started with a few of them. So let's look at D. Can anyone tell me D is a yes or no, and what are domain and range if yes?
I said D is yes.
D is actually a no.
Oh, what?
You got one input into 2 different outputs.
Oh, wait, I didn't even see that.
Okay, so that's a no. All good, all good. All right, what is E?
Yes.
Okay, what is the domain and range?
Domain is anything.
Okay, so we call it all real numbers. This is
Oh.
called all real. We don't even have to say all, just real numbers. Real numbers is who knows what real number means? I think Hannah, right?
Real number is just
Yeah.
like anything that can be defined, isn't it? Like,
Okay, so you got yes, something like that. You got integer, whole number, rational numbers, real numbers. I think. Oh, not integer. Sorry. Natural number, integer, which is the same as whole number. Rational number, real number. Okay. What about range, Adriana?
I don't know. I did like anything over -2, but
Over -2.
or like anything.
It's just anything. Okay.
Yeah.
All those -2 times x. you can find the input for anything. Let's say you got 1 as the output. You can find the input as 0.5. So anything can be the range. Or like, I don't know how to say it. It's just, yeah, anything. Don't say anything, say real numbers, okay?
Okay.
All right, anyone for F?
Wait, if I can't see it.
Oh, is it too small?
Yeah.
Oh, okay, let me zoom in a bit. Better?
Wait, no. You gotta go up, bro.
Oh no, it's F is on the screen.
I can't see it.
It's like right here. Do you not see
Oh.
it?
Okay, now I can see it.
Okay. That was like in the middle of the screen. I was like, what? Anyone?
Oh, isn't it negative infinity to infinity?
Okay, so that
All
is
real
everything.
numbers. All real
That is
numbers.
same as everything. Yeah.
Yeah.
Okay, I'm getting. Okay, I shouldn't say everything. It's called all real numbers. Okay, and then the range.
The range.
Yeah.
Range is also all real numbers, isn't it?
No, the range is only -4. You can't get the output. No, it says output. No matter what input is, everyone goes to
Oh.
-4.
Yeah, because there's no x. So. Damn. Okay. Choke of the century.
Does anyone else? Did anyone else get this, or does everyone failed?
What do you mean?
So did everyone get -4?
Yeah, well, I don't know.
Oh, nice. That's good. That's good. Because it's pretty hard. I don't expect you guys to get that one correctly straight away. All right, G. Anyone?
Not a function
Yeah.
Why?
because x is. Actually, I have no clue.
So if we graph this will look like this. Oh my God, I don't know why this is so messy. Let me make this a bit smaller.
Oh, is it because if you graph it, all the x's are the same?
All the axes are the same. That's a very weird description.
Like,
It's
if I
because
graph
it's
the
this vertical line, right?
yeah. So, like, as the y's change, the x's are the same.
So yeah, in other words, when the only allowed input is 3, but 3 gets you multiple output, which is very weird. Which is not allowed. So that's same input, different output. Okay,
So, it's not a function.
it's not a function.
Okay.
Okay, so this one you gotta kind of graph it and then see what it is. Oh, I kind of like this word. Oh, I kind of like this word. This is pretty convenient. All right. Where are we at? H. What about H?
Yeah,
Adriana.
H is.
Okay.
Oh.
Wait. Oh, okay. Okay, Adriana.
I said yes, it is a function.
Okay. Domain range.
Domain is anything, and range I was like a little confused. Like I was confused whether it was like 3 to 5.
Why is it not 3 to 5?
I don't know. Is it 3 to 5?
It is 3 to 5. So, like, why are you confused?
I don't know.
Okay, so yeah, range is 3 to 5. The notation will be this: y between 3 to 5. In this case, it includes 3 to 5, so make sure you have less or equal to sign. Any questions?
No.
Anyone for I?
I. Wait.
A real function.
That's a function, isn't it? Yeah.
Yes. What are the domain range?
the domain is infinity, isn't it? Or positive infinitely positive. Positive.
Yeah, you get the idea. But we say positive real numbers.
Oh, positive real numbers, my bad.
In other words, we say x bigger than 0, or bigger
Yeah.
equal to 0,
And
because it includes the point 0. Okay.
and range is then it would be smaller than 0 or
Yeah,
equal.
smaller equal to 0. Negative real numbers. Okay.
Yeah.
So real numbers means the continuous line. Okay. When we talk about 1, 2, 3, 4, these are discrete numbers. Or we call them whole numbers or integers. Okay. But in this case, let's say in this case, we don't call them integers. If we're looking at the domain, suppose it is a function, then the domain would just be these numbers because it doesn't have -4 or like positive 10, right? It's only these numbers. All right, just some concepts. J is too easy. We're gonna skip it. Let's do K. J is actually, yes. Yeah, let's do K. Let's do K. J is the same, by the way. So what is K? Is it a function?
Yeah,
Okay, why?
because like there are no outputs that are the same as like the x.
Okay, yes, you get the idea. A better way you could say it is, there are no inputs that will give you two different output. Or you can say there is a unique output for every input, which is the standard definition of the function. Okay.
Mm.
Domain and range.
Oh, I didn't do that one yet.
Okay, what do you think the domain and range is?
Is the domain like anything? I mean, like all real numbers?
Right.
Oh, I don't know.
Nope. Yeah.
Is domain everything equal to or below -1 and everything equal to and above above 1?
Yes, that's exactly. So you say x smaller or equal to -1, or in the comma, x bigger or equal to 1. So this is a domain. Okay. What about range? Anyone?
Range is anything smaller than -1 or anything bigger than 1.
That's
Big-
domain. That is domain.
Oh. Wait.
Output.
Oh, anything bigger than 3?
Bigger or equal to 3. Okay. All right. Any questions? All right, Adriana, how do you do I?
I said it wasn't a function
Why?
because the I don't know, the green line, like all of them give out the same output.
Having the same output is totally fine.
Oh,
So remember, two students can have the same grade, but we cannot have one student have two grades.
also
So
it
having same out. Okay. Brian, what did you get for this one?
The domain and range.
No. Is it a function?
Yeah, it is.
Hannah, what did you get? Okay, everyone knows it's a no now, but you guys all got yes. If I were you, I'd just answer no, because if it's a yes, I wouldn't keep asking everyone. Right?
Wait, why is it not a yes? Because if you think about like
It's a tricky one. It's overlapping on the 0.
What?
Oh, I get it.
Yeah.
Damn. Okay.
Oh,
So f of 0 gives you like 0 and 4, right? So it's overlapping on the 0, so it's not a function. This is a tricky one, okay? To make a function, we gotta draw something like this. Let's say we gotta do something like this. For example, we have empty point here, and then we have a solid point here. This will be fine. This indicates at 0, we are at. So this point indicates f0. Okay. Does this make sense?
Mhm.
All right, cool. We use graphic calculator. Yeah, can't be bothered with that. We move on. Any questions before we move on?
No.
All right, cool. This is pretty good about domain and range. Oh, this question is fun. Hannah, I think you asked me this question before. I thought it would be a good example to tell everyone. This is you got your function. I think it's like something like this: equal 1 over square root x minus 3 plus 7. What is the domain of this function if nothing else was given? All right, Hannah, you probably know this, right? Adriana and Ryan, think about it. Oh, before we do this question, let me just do another function, okay? Before we do this, let's just do a lot of few examples, because if we do this one straight away, it's a little bit too hard, I reckon. So before we do this one straight away, we did do, what is it called? Rational functions before. So if we have fx equals 1 over x plus 1, what is the domain of this function? Anyone? Except for
Isn't
Hannah.
it-
Hannah probably knows. Yeah.
Oh, isn't it? Hold on. It will meet at 1, at 0, and then grow further apart as the number continues to increase, isn't it?
Yes, that's what the graph looks like. But to find the domain, you don't need to find the graph. You just think about what can be the input, what cannot be the input.
Can't the input be anything? All real numbers?
Okay, you forgot what you did 2 weeks ago. Adriana, did you do this?
No.
Okay, Hannah, tell them the answer.
Isn't it? Wait. Wait.
Hannah's getting the peer pressure.
It's it has -1 in it, but I can't remember if it's bigger than or equal to -1.
So the intuition here is it cannot be -1 because when we substitute -1 in, this is 1 over 0. This is undefined. Okay? The domain is x cannot be -1. And why is this true? Why do we have this? It's because we cannot divide it by 0. Does this make sense?
Yeah. Oh my god,
Okay.
Yeah.
So another function, okay, that's one function. Adriana, does that make sense?
Yeah, kind of.
Yeah, this is also what we call the horizontal asymptote. If you've been to the lesson, you will know. If you haven't been to the previous lesson, you wouldn't know what this is, but that's the horizontal asymptote. Oh, sorry, vertical asymptote. CLE or CAL? CAL. Okay, remember anyone?
Mm-hmm.
Okay, we did this in the rational function before. That lesson was pretty hard, but it was okay. All right, so that's one example. Another example is, let's say if we have the function equals to square root of x. Before we go into the function, let's just have a look at what the function does. Adriana, what is, when x is 1, 2, 3, 4, what are the outputs? Just do one at a time. What is 1?
Wait, is F1?
No, fx is the function. The function itself is square root x.
Oh, okay. 1 is 1.
Yeah, f1 is 1. F is not 1, but like f1 is 1. Okay, we say f1 when this is the input, right? And this gives you 1, which is the output. Square root 1, which equals to 1.
Yeah.
Yeah, I should write it like this. Square root 1, which equals 1. So this is the output. Okay, so that equals 1. What about 2?
Is square root 2.
Okay, nice. 3.
Square root 3.
Okay, sounds right. What about 4?
2.
2. Nice. Any questions? Anyone?
Nope.
Now, what is the domain and range?
Wait, Michael.
Yes.
Or if open brackets, is that like a 1
Where?
in the green? Where you put input.
Oh, it's 1. It's 1, 2, 3, 4. Yeah. Sorry, I'm getting stressed out about this -1. It's supposed to be a negative sign. I think I forgot to move the negative sign. Okay. Yeah. So okay, I should be asking what is f of -1? Oh, it keeps jumping up. I hate it. Yeah, this is the problem with the word. Like sometimes it jumps because of the cursor, it jumps all the way up to the cursor. All right, what is f of -1? Anyone?
F of -1.
Yeah.
For the green.
Yes, for this function.
Isn't it meant to be that shouldn't it not exist? Isn't it like imaginary?
Yeah, square root and -1 is undefined, okay? At least for you guys, it's undefined. There's a concept, okay, this is called imaginary number, okay? This is called imaginary numbers. Imaginary number. What a
Wait.
fancy name.
Are they like pi?
Undefined for high school.
What the hell?
All right. Yes. So just treat it as undefined. Yes, it's probably undefined in 2D, like in terms of real numbers. So here, what is our domain and range? Yeah, that's the question we want to investigate. What is our domain and range here? Anyone?
Is it all positive numbers?
Okay, that's domain? Sure. What about range? Anyone?
Range would be
All right, Hannah.
What do you want to find both domain and range?
Yeah, yeah.
Domain can't be 0.
It can't be negative. In general, so this is the one where you have x bigger or equal to 0.
Oh,
It can be 0, it can't be negative. You can't square root negative, okay?
yep.
What is the range?
It can. Wait, is this the one where if you don't have a number behind it, it's 0?
A number behind it?
Wait, I think I forgot.
Okay, so you already know it cannot square root a negative number. The domain is positive. So when you square root a positive number, you get another positive number back, right? And you never go to a negative number. So the range is also bigger or equal to 0. Okay? And the graph, in fact, the graph looks like this. It's because this is the inverse of a quadratics, right? The graph looks like this. It looks like a horizontal cut in half. It's like a horizontal cut in half quadratic graph.
No,
Quadratics is
range-
this.
range- Oh wait, no, you already wrote it.
Hmm?
Never mind. Keep going.
Yeah. So this is the inverse. This is the opposite, what we call inverse function of a square. So this function here is f. Oh my god, why is this texture? I don't want this. This is a pencil. No, I don't want a pencil.
Wait, so Michael, which one's the one
Yeah.
where the range is y does not equal to 0?
Does not equal to 0. Oh, a range. Oh, range is that way. I might have screwed up here. Oh no, we didn't even talk about the range here. But this one, yes, this one range is does not equal 0
Oh,
because
is it fractions?
yes, rational numbers because they are horizontal asymptotes.
Yeah.
Okay, but I forgot to
But
talk
I
about
thought it
it.
was for this one.
No, it's not this one. Don't hard code remember it. Remember the reason behind it, and you'll never get mixed up. Okay, so this one is it's because it's square rooting. It's the opposite of the quadratic function. So this is y equal x squared, and you flip it sideways. Flip the axis, x and y flip. This is y equals square root of x. Does that make sense to Ryan? Does that make sense?
Yep.
Adriana, does that make sense?
Wait, could you say that again?
So because this is the opposite, so this undoes the square. The square is quadratics, right? It looks like this. Square root undoes the square, okay? So let's say square, you have 1 and gives you 2. This one, you put 2 in and it gives you 1, something like that, right?
Oh, yeah.
So let's say this point here is 1, 1, right? For both of them. And then here I have 2. Oh, sorry. So, oh yeah, you have 2, and then this gives you square root 2. But for this quadratics graph, oh no, let's not use that. Let's use 4. Let's say you have 4. And then it gives you 2, right? The square root gives you 2. But for the quadratics, if you have 2, it's going to give you 4. Okay? So that's why it's flipped. It's flipped along this axis.
Oh, okay.
The input output is flipped. So there's a whole topic on this called the inverse functions, and we're gonna cover that today later. Right now we're just gonna do some more domain range. All right, so yeah, for square root, they have to be positive input, and then that gives us positive output. All right, what about, okay, finally you guys can do this question. Try this question, see what is the input and output. Hannah's already done this. Okay, Hannah, I'll make you explain this one later. Yeah, so maybe you can prepare your explanation a little bit. Practice like speaking it in your mind, okay?
Wait, I feel okay, yeah.
Okay, good luck. All right, Ryan and Adriana, you guys can try to find the domain. Just the domain, not the range. You don't have to find the range. Range is a little bit too hard. I'll give you guys like 2 minutes, I think. All right, Adriana, Ryan,
Yeah.
for one of you who get the question first, I'll give you guys a chocolate from Japan.
How you gonna get it to New Zealand, mate?
I'm getting back in the month, and then Adriana is in Sydney. I'll give you guys a chocolate from Japan. This chocolate is very good, okay? Oh my god, there's lightning outside. Oh my god, in Sydney. It's crazy.
So denominator can't.
So can we change x to 0?
What do you mean change x to 0?
Well, I mean like x is 0.
Why do you want to change x to 0?
I mean like if it's 0, then like it's like
Ah, here, the key is you don't change x to 0. You can't divide by 0, not you can't have x equal 0, okay? So the denominator, it can't be 0. Does that make sense? Okay, oh, by the way, sorry guys, I made a little mistake. I don't know if I spotted. It should be -7. Otherwise, it's kind of useless. All right. Hopefully that doesn't affect any of you.
Oh hell no.
Yeah. So the denominator can't be 0. Right. That's one criteria, and another criteria is that you can't square root a negative number. These are the two criteria you're looking for. I'll give you guys 2 more minutes, maybe 1 more minute. Hannah, have you prepared your explanation?
Wait, can I send you the answer that I got and then you just check? Because I'm not.
No, it's okay. I believe in you.
Wait, how do I?
No, even if you get it wrong, it's okay. It's okay. I will correct you. It's okay. Adriana, is lightning right above Bondi. Do you hear it?
yeah, I hear it.
How much time do we have left?
Just keep going. Anytime soon. If you feel like you're making progress, just tell me. I will give you some more time. So are you making progress?
Yeah. I've gotten
Okay.
like the square root part sorted. I'm just thinking of the -7.
Okay. All right, Hannah, explain. And then we can have a break.
Wait.
Wait. Oh.
Why do we have to wait? What's wrong?
I think I cooked, but I don't know if I'm right.
Okay, Hannah, explain.
Wait.
It's okay. If you get it wrong, I'll correct you. No stress.
Um. wait, for one of the domains I got x is bigger than or equal to 3.
Okay, why is that?
It's because of the square root. Wait, no,
Okay.
square root. I have no clue.
Okay, I'll tell you it's correct. So how did you get that?
I don't know.
Okay, so being able to explain is very important, okay? It helps you to clear your mind. It helps you to reinforce your knowledge and makes you stronger over time, okay? All right, so I'll explain that one. So as I said, the two criteria we're looking for, one of them is you can't square root a negative number. That means x minus 3. This is the part inside the square root. This is inside the
Okay.
square root, right?
Can I do my explanation?
Okay, yeah, sure.
I think I got it. Well, since we can't divide by 0 or below, right?
Yeah.
I first did. So for the square root part, it has to be bigger than 3, otherwise it becomes 0, right? Equal or bigger than 3.
Yep, something like that. So this part is
Yeah.
the part that's inside the square root. And
Yeah.
we know that part must be bigger than 0. Bigger or equal to 0. So we get x bigger or equal to 3. Okay. Hey, Gianna, does that make sense?
Yeah.
Okay, so yeah.
And then
Yep.
my next part was for the 7 part, I was so lost,
Yeah.
and I was thinking if we reverse it, it would give us 0, right? So like if we did the equation equal to 0, we would find when it becomes 0 again.
So what equals 0?
When the bottom part becomes 0.
Okay, sure. So yes, we cannot divide it by 0. So we kind of solve this, right? This does
Solve
not
for
can't equal to
x.
0.
Yeah.
Yeah.
So plus 7
Okay.
square 49 plus 3, 52. And if we look at this, we plug 52 into it. 52 minus 3, 49, square root 49, 7, 7 minus 7 equals 0. 1 over 0 can't work.
Exactly, that is correct. Good job.
Is it everything?
Hannah, did you get the same thing?
Yeah.
Okay, Adriana, did you get the same thing?
I got that part, I just didn't do the other part. Like,
You didn't do this part.
no, I did that part.
You
And then,
didn't do this part.
yeah.
Okay, so two of them. There's a square root and there's a fraction. There are two things to it. And yeah, so if you're looking at a number line, it would be something like this. So you got the 0 here. You got everything above and including the 3. Everything above and including the 3. All the way until 52. You can't have 52 and keep going. So you got a 3 here. Hey, Jonah, did you hear that?
Yeah.
That was so loud. The entire Eastern Sydney could hear that. Oh my God.
Oh, yeah.
Okay. I don't know if you heard it, but that was like crazy loud. Some poor tree just died. All right. Any questions before we have a break? No questions. All right, we'll have a 7-minute break. We'll come back at 5:20/7:20. Okay.
Okay.
All right. Be right back. Hello, everybody.
Hello.
I'm observing the lightning in the meantime. Ah, this is crazy. All right, so for the remaining of our today's lesson, we're gonna do composite functions and inverse functions. That's the hard part about functions. Okay. Okay, I wouldn't say composite functions hard. Composite functions easy. All right, so what is composite functions? So now let's get to the algebra side. Let's say you have f, and someone give me an f and someone give me a g. Adriana, give me some random functions. Anything works.
What? Like,
Give me any function you like.
I don't know.
Anyone.
Rational. What?
No, a specific one. Specific example. Like y equals mx plus c, anything like that.
Oh, y equals mx plus c.
No, mx plus c, I want actual values for m and c.
Y equals 1 plus 2. Wait,
Okay, let y equal x plus 2. Oh my god, it's lightning in my face. Did you guys see my face went bright for a moment?
Yeah,
That was crazy. Huh?
I did see.
That was crazy. Oh my god. Okay. First function fx plus 2. Ryan, give me a second function. Call it g.
X plus 3 over x plus 4.
Nice, nice, nice. Okay. All right, Hannah. Okay, actually not Hannah. Just everyone. What is f bracket g bracket x? So this is what we call composite function. Okay. So what do you think this is?
You put the g in the f function.
Yep. Try to like write it down on paper. See what you get. Okay. That was another lightning in my face. I'm gonna turn off the light and then record some lightning pictures while you guys do the questions. Oh, tell me when you finish the question, okay? Just message me when you finish the question.
I finished.
Okay,
I finished.
nice.
I
There
think
was another lightning in my face. Okay. What is it, Adriana?
I finished as well.
Okay, cool. What did you get for? Okay, Adriana, what did you get for f of g?
Well, wait, I thought we had to like we substitute like
Yes.
this was like 1, and then so I did like f bracket 1 plus 3 over 1 plus 4. And then
No, you don't substitute. Why did you substitute f equal 1? What made you think you want to substitute that?
Loki don't know.
No, the 1 was different. The 1 before was the 1. No, we didn't have any 1s before. No. Okay, Ryan, what did you get?
I got 3x plus 11 over x plus 4.
Oh, okay, Hannah, did you get the same thing?
Wait, I don't know. I just did x plus 3 over x plus 4 and then plus 2.
Okay, yeah. Okay, so f of gx is you're putting gx into f. So what is gx? Gx is x plus 3 and x plus 4, right? You could do this. So this is x plus 3 over x plus 4 plus 2. So this is a composite function. You put two functions together and you get a new function. Does that make sense, Adriana?
Wait, where's the plus 2 from?
Oh, so you're putting this inside f, right?
Oh,
So
I
this
forgot
part
about that.
replaces x.
Oh,
And you want to you can simplify this. Plus 2 is pretty much plus 2 times this on the top, right? You got 3x plus 11. Is that what you got, Ryan?
Yeah, 3x plus 11.
Okay. Oh my god, that's another lining in my face. Alternatively, oh, any questions, by the way?
no.
You can write it like this, because it's f of gx. So this is gx plus 2, right? So you do f first, and then you do g. Previously, we did g first, but we still get the same thing, right?
Okay. I like forgot about x plus 2. Like I didn't.
No, it's okay. Oh, there's a pink dot on my screen. What? Do you guys see the pink dot on my screen? I think it's
No.
from Zoom. Okay, I did erase it. All right, so that's composite function. Let's have some practice with composite functions. It's right here. This is very good. I don't know if Hannah have done this before, but this looks very emotional damage.
What?
This looks very emotional damage. All right, everybody do these.
Oh my god, what the fuck?
So start from 1. I'll give you guys like 10 minutes. Do as much as you can. And if you have any questions, please tell me. Okay. There was another lightning in my face. I'm just enjoying the lightning show right now. You know, a lot of photographers in Sydney, they love these because Because in Sydney, the lightning is really frequent and you could have some really sick pictures.
Wait, Michael,
Yep.
what for these, you know how fx has two x's?
Yes.
Which one do you substitute them with?
Both.
Oh, okay.
Technically, you can complete a square to make it 1x. So there's no difference. You gotta substitute all the x out. Right, let's say, just do a very basic example. What is f of 1? Can you tell me? I know, what is f of 1?
1 plus 5 equals 6.
-1 plus 5.
Oh yeah, -1 plus 5.
Cause negative equals 4. Okay. So in this case, see, when you're substituting 1, you put it in both of the x's. So when you're substituting something else, you want to put it in both of them as well. All right, if you finish part 1, tell me, but I don't think you guys are gonna finish part 1 that fast.
Part 1, huh?
Yeah. Oh, sorry, part A.
Wait, Michael, for the x, you never want, like the x squared, you never want it to be a negative, right? Michael?
I'm thinking, yes, I'm thinking.
Oh,
No. It will never give you a negative, but you can put a negative value in there. For example, what is f -1, right? And tell me.
f -1. It's just -1 squared plus 5x. I mean 5
Mm.
times.
No, it is -1 squared plus 5 times -1.
Oh my. That's
Which
why.
is -1 minus 5, -6.
Yeah. Okay.
Oh my god, guys, I just captured the most perfect lightning in the sky. It was like a good. My phone was on video, and there was this lightning literally across the sky in the middle of the camera, and then I caught that on camera.
Unlock.
I'm gonna send that in the group chat.
Let's just.
Now we
Oh
have a
God,
25.
it looks so. I'm about to crash out.
What's wrong?
3. I'm just looking at 3, and it
3
looks.
f of h. Oh, it looks fine. Kind of simplify a little bit, but don't simplify too much. You don't have to simplify too much, but you do want to simplify it. Okay. This is fine. H squared plus 5h. That's totally fine. H, that was okay. That's the algebra practice I think everyone should have more of. Because yeah, if you're good at algebra, your high school math is probably just easy. It's very easy. Okay, I think we'll do this until maybe 45. And then we'll spend the last 15 minutes on inverse functions. The key here is we don't have to get through everything, but I want to make sure you guys get enough practice so the lesson's worth it. We don't have to cover like every single concept in the functions chapter, because everything, like for your school, you probably spend like 2 weeks on this, right? We can't just finish it in like 2 hours. Hannah, do you find this too easy or is okay?
I think it's okay.
Okay, that's good. Adriana, are you finding this too hard or is okay?
It's in between.
In between, because you didn't come to the first lesson. That definitely makes it so much harder.
Yeah.
But yeah, I'm trying to like re-explain everything. It should be fine. By the way, for the f1 and f-1, Adriana, do you get those?
Huh? Oh.
Yes.
Yeah. I do.
Okay, that's good. That's good. I just captured another perfect lining. I'll send you guys the lightning photos in the group chat later.
Michael,
Yo,
for question 4, what does the dot mean?
question 4. The dot
Is that just
means
multiply?
the dot. Okay, this is another notation. This reads g of h. Okay. So we have g o h of x. Okay, wait. Let me write this properly. So g of h and then x. This is exact same as g bracket h bracket x. Okay.
Oh wait. Is that it?
Yeah, it's exactly the same. It's just it's a different set of notation. That's all.
They write it like that.
It's a different set of notation.
Literally had me panicking.
All right, one more minute, guys, and then we'll start explaining. Hannah, which one you up to?
I'm on 4.
Okay. Adriana.
I'm on 3.
Okay. I think the homework will be completing all of these. Okay. I'll leave you guys some homework, and please do them if you have time, because that will exponentialize your progress. I don't even know if that's a word, but yeah. The homework will be completing these and try to find the range and domain. And we'll spend the last 15 minutes on inverse functions. All right, so who wants to give me the answer of the first one?
Oh no. Chat.
Anyone?
I'll do it.
Okay.
Let me find it because my working is like really big. Okay.
Okay.
Well, first I did was substitute into it.
Okay.
Oh wait, do you want the answer or just explaining?
Explaining.
Okay, so I substituted into it And since g is 4x minus 2, what I did was, and f is negative x squared plus 5x, I did negative open brackets 4x minus 2 close brackets squared plus 5 open brackets 4x minus 2 close brackets. After
Looks
that,
about right.
I expand it, and it is a squared 2ab and then b squared, right? So it's
Yep.
16x squared minus. Wait, am I right? No, I'm not. Huh? Am I? Expand the squared term. Expand this.
See, that's the algebra I'm talking about. Although we're doing functions, we are practicing a lot of algebra here, and that is very useful. Okay?
Oh, wait. Yeah, it's still 16x squared minus 16x and then plus 4.
Okay.
Then after that, I just plugged it all back in since it's still the same. And then I expanded the 5x, the 5x one.
Mm-hmm.
So
Did you get 20x minus 10?
oh yeah, 20x minus 10.
And lastly, we want to collect the like terms. So x squared is there's only minus 16x squared. For the x, we have minus minus, that's plus 16 and plus 20 plus 36x.
Yeah.
And this minus 4 minus 10 minus 14. Did everyone get this?
Yes,
Nice, nice. That's a lot of working. Adriana?
I got that.
Nice. That's very good. Very good. Okay, so that's very good. If you make a mistake, that's fine. If you make a mistake, that's totally fine because there's a lot of algebra to do. I'm trying to group everything. Oh, what is wrong? All right, anyone wants to do 2? Actually, Adriana or Hannah, one of you.
I can do it.
Okay.
So first you negative minus x squared plus 5x bracket squared.
Sorry, say that again.
Minus
Yeah.
bracket minus x squared plus 5x
Yep.
squared
Yep.
plus 5 bracket minus x squared plus 5x bracket.
Yep. That looks right. All right. I'm just gonna simplify it for you guys just to save some time because we are running out of time. Oh, and the lightning is still going. Just keeps going. I'm getting so much good clips. All right, so we expand the first one and then it's the same. Okay, leave the minus sign out because the minus sign applies to everything inside after the expansion. But if we apply the minus sign too early, it's gonna ruin the expansion. So we do the square first, okay? We get x to the 4. This negative sign do cancel out on 25x squared and then 2ab, right? It's a minus from this minus x and 2ab, that's 10x to the power 3. And then we get minus 5x squared plus 25x. And here we start with the highest term, x to the power 4, and then the x3 term. So minus 10, so it's a plus 10, x3. And then for the square term, it's minus 30 in total. And then for the x term is 25. Does everyone get that?
Yeah.
Okay. Okay. That's very good because I wasn't expecting everyone to get that. There's a lot of algebra. You could have missed the minus sign on the way, but if you got that, if you get it, that's very good. Ryan, did you get it?
Yeah.
Okay. All right. That was interesting. No one made a single mistake. That was very interesting. Okay. And then what do we have? Let's do, okay, let's do question. Did everyone do question 4?
Yeah.
Hannah?
I finished the starting bit. I didn't get like the final answer.
Okay, sure. In that case, let's do question 4 and then let's see what we can get. Okay. So we get g of h of x. So g is 4x minus 2, and h is, you plug that in. Ryan, would you want me to check question 3 for you as well?
No, I'm fine.
So you too confident with that?
Nope. I just don't want
Okay,
to.
so question 4 is easy. It's pretty much this. Plus 4 minus 2, so plus 2, right? That's easy. Oh. So that was quite easy. And then lastly, let's just do these 3. And lastly, let's do question 5. Okay. No one probably done question 5, but everyone spend 1 minute and have a look, see what you can get. I'll give you guys just like 1 minute to do it
No.
and see what you get.
I
Okay.
don't even want to try. That looks so copious.
Now it's easy. I'll give you a hint. You don't find f straight away. You find f1, plug that value back in f 2 times more. So it's actually easier than the algebra you did before.
Okay.
Oh my god, I just captured the most perfect lining. I'll send it in the group chat. That was crazy good.
Oh, wait, never mind. It's not even that hard.
I know it's not that hard. Oh, that's crazy lightning. I'm gonna send it in the group chat. Alright, if you guys are interested, you guys can check the group chat. Oh my god, 73 MB video. Yeah. Alright, time's up. What did everyone get?
I got minus 4,686. Or negative
Okay,
4.
I have no idea, but let's see. So this, we already got f -1 equals -6, okay? So let's plug that in again. We put -6 in there, see what we get, okay? That is f -2 plus, oh, oops. That is -36 plus 5 times -6, which is minus, 76, right? And lastly, we do f minus 76. All right. You know what? I'm gonna put this here as a reference. And now, okay, if we look at what this is really saying, this is saying f bracket, f bracket, f bracket, -1 bracket, bracket, bracket. We know this part is -1. Sorry, this part is -6 because of this line, right? So this equals to f bracket -6. And we know this part equals to -76. So this equals to f bracket -76, right? And that equals to minus 76 squared, minus 76 squared, plus 5 times -76. Is that what everyone got? Hello?
Yeah.
Yeah.
Well, I'm kind of lagging.
Oh,
So
okay.
am I?
Maybe it's me. I don't know. Hannah and Adriana, is that what you guys got?
I think so.
Okay, so the key here is to substitute the numbers before you compute f. Because computing the function in the general form is very hard. But if you have a single value you can find, you just keep finding that value until you get it, okay? And then after that, you use a calculator. Yeah, you can use calculator for this. 76 squared is hard enough. Probably use calculator for that. You find some values, and that's good. All right, any questions before we move on? Yeah, initially I was gonna leave some more time for, oh, oh my God, my Word document literally just died. Hopefully the notes are here. Oh, the notes are here. I need to save this. All right. My Word document just died, and then now I'm restarting it. All right, I was gonna leave more time for inverse functions, but turns out we don't have enough time. So I'm just gonna briefly introduce to everyone what is an inverse function, okay? So let's say you have f of x. This takes the input, okay? Let's say you have f. This takes input to output, okay? All right, this also explains the notation Ryan was asking. Remember the notation, we have something like f bracket and then x arrow, and then say like x squared plus 1, right? This is the same thing as f bracket x equals x squared plus 1, okay? Notation, either way is okay, okay? But suppose we have f equals that. We have its corresponding inverse, okay? F minus 1. This takes the output. So this takes the let's see how to say this. Original output and gives you the original input. Does that make sense? So let's illustrate this with an example. So let's say we have f. Why is it blue? I wanted to have green. Yeah. So let's say we have f x equals x plus 1. Then your inverse function would be x minus 1. Okay. All right. Ryan, if we have fx equals 2x, what is your inverse function?
Negative 2x. Or I mean x over 2.
Yes. X times 2, x divided by 2. So x over 2. Okay. Adriana, if my f is x squared, what is my f inverse?
Is it 2 square root x?
No, we did this before. We did this before today. That's why I'm asking this. What is this? How do you undo? Yes, you do square root of x. Okay.
Yeah.
So you undo what you did.
You could have a look at this. Okay, if we have value, let's say this is your x and this is your output, fx. Fx is, you can treat as y. Okay, let's say 1, 2, 3. What do you get here?
Huh?
What
Oh,
do you get
one-
for f? Yeah.
1 square root 2 and square root 3.
No, I'm talking about fx.
Oh, 1, 2, and 3.
No, 1, 4, 9. You square them.
What? Oh, squaring.
Did you miss the square?
Yeah.
Okay, so for the inverse, it takes literally the opposite of that. So if we put 1 in, square root of 1 is 1, right?
Uh-huh.
And square root of 4 is 2, square root of 9 is 3. It's exact opposite, okay?
Okay.
They're exact opposite. Okay, it kind of undo each other. Okay? All right, Hannah. I give you a harder one, okay? Actually, Ryan, I give you a harder one. 5x minus 1 over 2. What is the inverse? Oh, Ryan is gone. Oh my God, what? Just ask. I was, okay. It's okay. We are about to finish. See you next week. I typed it to Ryan. Okay. All right, Hannah, the hard question falls on you. What is this?
2x plus 1 divided by 5.
Nice. Okay, Adriana. The key here is that we step by step undo what we did. Okay.
Yeah.
So let's look at this. We have, let's say, we have f of 3. Can we do that? Yeah, f of 3. What is this, Adriana?
F of 3 is what?
Yeah.
It's
Why is this doing this?
Uh.
All right. Yeah, don't worry about it. It should be fine. Okay. Yeah. What is it?
it
Oh my God, I can't believe this is choking. Okay. Yep.
wait.
I'm not gonna touch anything.
Is it like wait,
Just
I don't-
F. No
F.
inverse. Just F. Just F. Not an inverse.
Hmm?
Just the F. I'm not asking anything about the inverse right now.
So you asked me what is F?
What is F of 3? So what is F of 3? When you
Oh.
substitute 3 in.
3.
What? Is
Wait,
it?
in that question, isn't an
Hmm?
F, isn't it just like 1 bracket 3 close bracket? Like, isn't it just
1 bracket 3 close bracket?
isn't F just 1?
Which F are you looking at right now?
The example F?
The 5x minus 1 over 2.
Oh. Oh. Oh.
Which one are you looking at?
I thought you were just asking me what F of 3 was.
No, F is just a name. It's like a variable. It's a function name. It changes all the time.
Oh yeah, okay.
I'm talking about a specific function, right? When f is x squared, f of 3 is 9. When f is 2x, f of 3 is 6, right?
So it's 7.
So, well, right now it is 7. Okay, 5 times 3 minus 1, right?
Yeah.
It is 7. All right, so now let's try what is f of inverse of 7? What do we get? Adriana.
3.
See? Exactly the opposite. And if we look at the steps that we did, it's actually the opposite of what we did, okay? So step by step, we undo everything, okay?
Okay.
This is very important, okay? That's the key of inverse function. And that is how Hannah got the answer in such a short time, is knowing the concepts. All right, any questions before we finish today? The homework will be completing these.
Okay.
No question?
No.
All right. If there's any questions, feel free to ask me anytime in the WeChat. I'll see you, Adriana, tomorrow and Hannah on Thursday, I believe.
Yep.
All right.
Thank
Goodbye, guys.
Thank you. Bye.